All right, so for this example of why a data collection is so important, I'm recreated a slide that was presented to a math department that I worked at by a publisher representative. So this publisher rep was selling how great their software was because it was adaptive and it helped students figure out what they didn't know and showed a graphic that looks similar to this. Obviously it's been a long time. Don't exactly remember what the bar chart was, but something like this. 60% of the students who were in sections that didn't use the software did not succeed in the class, whereas 80% of students who were in classes that used the software were successful. Look at this huge improvement that the software gave them. And so I hope that you are, similar to me, which is, again, a bit of a curmudgeon. And you're sitting there going, I feel like there's a bit of a red flag here. There's something more going on. So of course, me being me with my stats brain, I asked some questions. And so maybe if those questions aren't percolating in your brain yet, pause, think about what questions I'm going to ask. But the questions I asked were, well, what class was this? Actually, that was in the title. I didn't recreate that. I think this was like Algebra 2. So this was like all Algebra 2 sections. Okay, well, how did you collect the data? Well, we just figured out all the Algebra 2 sections, looked at the success rates, and that's where these numbers came from. Okay. Okay. So, I mean, it's basically a census. They didn't like leave any groups out. Okay. So I can't like fault them on how the data was collected per se. But then, well, how did you decide who was going to use the software and who wasn't going to use the software? Oh, okay. So for that, they went to the teachers and the professors and they did a similar pitch that they were doing to us, how great their software was. And the professors who felt like the software was going to help, they used it. The ones who didn't use it. And I'm sure you've encountered very different professors in your time at Mesa, but not all professors are equal, and not all professors, uh, let's say, care. I don't know if that's the right word, but maybe possess the same enthusiasm for trying new things as I unwittingly did everything this semester, which was not bright. But we're going with it. So I'm sitting there going, well, I'm gonna like relabel this label instead of use software. This is students who were in classes with professors who were willing to try a new software program. And instead of didn't use software, this should be students in classes that professors were unwilling to try the new software. And of course, they may have been unwilling because they were unimpressed. They had something else. They didn't like that it was paid. Who knows? I bet this was offered as for free to these students, but who knows? If I had something that was for free for my students, I would employ it just as an option. But I'm now thinking there's a big confounding variable. I'm using a definition from section 1. A big confounding variable here in that the professors themselves are different. We're not comparing apples and apples, we're comparing apples and oranges. Now, if we had randomly assigned or we had professors who had done both and we were just comparing those, I'd be impressed by this data. But as it was, I was unimpressed for this very reason. So the next thing I want to talk about is that generally speaking, this data collection is something we should always be concerned about because depending who answered the questions, depending on how the data was collected, whether it was done in this sort of observational way, we can make different conclusions and there can be really big problems with what our conclusions are. So to give a historical example, back in 1936, so like I said, historical, uh, there was the biggest poll ever done. So there was an article in Insider, an article in the Wall Street Journal. There's articles everywhere talking about this blunder that happened. And it was a big deal because Literary Digest, which was like the magazine of the times, did this poll and they polled like 1 million people. They sent out 10 million straw ballots, right? Polls asking people who they were going to vote for. It was the biggest poll ever done. Still, I think to this day, the biggest poll. Humongous. And they said that Al Landon was going to beat FDR. You've never heard of Al Landon. There's a reason. Um, 57% to 43%. So by a large margin, almost 14 points, right, that they gave him. So they said, okay, we are convinced that this is going to happen. And they had correctly um, predicted the last couple. So it was a big deal. People really thought this was going to happen. And then people went to the polls. Roosevelt actually won 62% to 37%. Like just trounced Al Landon, which is why we have never heard of him. Um, so this was a big blunder, and the reason for this blunder was all due to data collection. The Literary Digest decided they would collect their data by reaching out to people calling their phones. But in 1936, uh, not everybody had phones. And the people who had phones were, you know, definitely more affluential, right, than the more affluent, sorry, than those who didn't. So yeah, they grabbed phone numbers, they grabbed country club registrations, they grabbed driver's registrations. They're basically going with all of the places that the affluent part of the population would be: country clubs, cars. They have a car in 1936 and they have a phone in 1936. So for all these reasons, they collected a huge amount of data, but only from this part of the population that wasn't representative. And so there have also been postmortems sort of done on the 2016 election, right? If we want to get to something more recent, when almost every right media outlet was saying, look, they've done polls and Hillary Clinton is going to win the 2016 election. They were calling it, right, based on these polls. And there have been a lot of postmortems on why this happened. Some of it is just due to how statistics is then talked about in the media, right? We have personalities and anchors who don't really understand what the polls are saying. So they're making those statements a little more confidently than they should. But there's also some things that have gone down that are related to data collection, because a lot of the way the pollsters collect data back in 2016, they did a lot more random digit dialing, and they also did um, a lot more intentionally reaching out to likely voters, people who had voted in past elections. And 2016 ended up with a lot more people who don't, because there are a lot of registered voters who don't make it, right? Our voter turnout is low. But that election drove a lot of people to the polls who don't typically go. And a lot of it also was modeling, which gets into the analysis piece of it, where they kind of weight based on all these responses. They've realized now that they need to weight more based on education level than they were previously, and reach out to um, more diverse people when they're doing these polls. But all that aside, the data collection is a big deal, right? If you set up your data collection incorrectly, it doesn't matter how much data you actually get. If you use observational data to say something that is causal, right? Like, look at what our software has done, you're misrepresenting what you did. So that's all stuff that we're going to get into in part one, as well as some very specific ways that we collect data and a lot of the terminology associated with it.